Welcome back everyone. Today we'll be seeing what is a graph and what is its contribution in the subject of data structures. So let's begin. The learning outcomes out of this entire presentation is going to be able to explain the graph and the related terminologies, to be able to represent the graph using something known as an adjacency matrix or an adjacency list. Now, what is exactly a graph? Now, you must have heard regarding what is a graph in your lower classes also. But what role it has to play under data structures is something which we are going to see over here. So, let's try and understand this is a graph. Now, what is this exactly? This is actually a combination of different nodes and different edges. So, we call these as your nodes or vertices. Either it's node or a vertex, and this is an edge. Now, an edge can be of two different types. One can be a kind of undirected edge where you do not have any direction, like these ones. These ones which we can see are undirected edges, whereas few edges we can have which are directed. That means there is a direction, let's say from A to B or B to E respectively. So, a data structure that consists of a set of nodes and a set of edges that relate the nodes to each other. The set of edges describe the relationships among the vertices. Then, how can we formally define a graph? A graph G, we usually represent it in the form of G. So, a graph G is defined as G is equal to VE, which is a collection of vertices and edges. VG, a finite non-empty set of vertices. That means for a graph to be active, there has to be at least specifically two vertex. If there is no two vertex, we cannot call it as a graph. And EG is a set of edges, that is a pair of vertices. Now, let's try and understand what is the difference between directed and undirected graphs. Now, if we check this is an undirected graph. This is an undirected graph. Now, why this is undirected? Because there is no directions present between the edges of A, B, C and D. So, you do not know whether the edge goes from A to B or it's from B to A respectively. So, we call it as undirected graph. So, when the edges in a graph have no direction, this graph is called as undirected. And vice versa, if I have a vertex or an edge in this way, let's say I have a graph in this way, and I have direction specified. Let's say this edge goes from B to A, this edge goes from A to C, and this from B to C respectively. So we call this as a directed graph. Now, specifically, what are the differences between trees and graphs? Trees are specific cases of graphs. So we have already studied trees in our previous lectures. You may just visit those videos if you just want to have an overlook of what is exactly a tree. Now, this, if I say, is a directed graph as I discussed in the previous slide, because I have some directions from one vertex to another. Although this is a kind of a tree, but still this is again a special case as discussed over here of graph. So tree is also a kind of graph. Thank you everyone.